Second derivative test rules can be used to determine relative maximum or minimum. If the second derivative of x is greater than 0, then f of c is a relative minimum. If the second derivative of x is less than 0, then f of c is a relative maximum. If the second derivative of x equals 0, then the second derivative test fails and you should use the first derivative test. C is the critical points found from the first derivative. Our first example is f of x equals sine x plus cosine x. The first thing you need to do is state the domain. Since this is a trigonometric function, the domain is 0 to 2 pi. Next, you need to find the first derivative. So f prime of x equals cosine x minus sine x. Next, you need to set this equal to 0. And then solve for x. In this case, x equals pi over 4 and 5 pi over 4. Then you need to find the second derivative. So f double prime of x equals negative sine x minus cosine x. Then you need to plug the critical points, which you determined from the first derivative, into the second derivative. So f double prime of pi over 4 equals negative sine of pi over 4 minus cosine of pi over 4, which yields a negative number. Then you need to plug 5 pi over 4 into the second derivative, and it's negative sine of 5 pi over 4 minus cosine of 5 pi over 4, and this yields a positive number. So by the second derivative test, we have a relative max at x equals pi over 4, since it is a negative number when you plug it into the second derivative. And then we have a relative minimum at x equals 5 pi over 4, because it's a positive number when you plug it into the second derivative. Then you need to find the y values for each. And so you have pi over 4, and then when you plug it into the original function, it's the square root of 2, and then you have 5 pi over 4, which when you plug into the original function is negative square root of 2. So this is the answer to this problem. For our next example, f of x equals x over x squared plus 2. So the first thing we need to do is state the domain, and the domain for this function is negative infinity to positive infinity. Then we need to find the first derivative, and to do this we will be using quotient rule. So f prime of x equals x squared plus 2 times 1 minus x times 2x all over x squared plus 2 squared. And this, when simplified, will equal negative x squared plus 2 all over x squared plus 2 squared. And then we need to set the top equal to 0 in order to find our critical numbers. So negative x squared plus 2 equals 0. So x squared equals 2. And so our critical numbers are x equals plus or minus the square root of 2. Then we need to find the second derivative. And in order to do this, we will need to use the quotient rule and the chain rule. So f prime of x equals negative x squared plus 2 over u squared, and u equals x squared plus 2, and u prime equals 2x. So then f double prime of x equals u squared times negative 2x minus negative x squared plus 2 times 2u prime all over u squared squared. And so the first thing you can do with this is you can take a u out of the first two the top terms and then cancel that out with 1 on the bottom. So f double prime of x equals u, so that's u times negative 2x minus 2u prime times negative x squared plus 2. And this is all over u to the 4th. So you can cancel this out and make this a 3. And so then what you need to do is you need to plug your u and u prime back into this equation. So f double prime of x equals negative 2x times x squared plus 2 minus 2x times negative x squared plus 2 all over x squared plus 2 to the 3rd. And this all simplifies to 2x to the 3rd minus 12x all over x squared plus 2 to the 3rd. So now we need to plug our critical numbers from the first derivative into our second derivative. So f double prime of square root of 2 equals 2 square root of 2 to the 3rd minus 12 square root of 2 all over the square root of 2 squared plus 2 to the 3rd. And this yields a negative number. Then you have to do f double prime of negative square root of 2, which equals 2 to the negative square root of 2 to the 3rd minus 12 times the negative square root of 2 all over the negative square root of 2 squared plus 2 to the 3rd. And this yields a positive number. So by the second derivative test, we have a relative max at x equals the square root of 2, because when you plug it into the second derivative it's negative, and we have a relative minimum at x equals the negative square root of 2, because when you plug it into the second derivative it's positive. Then you need to plug both of these back into the original function to find the y value. So the square root of 2, its y value is the square root of 2 over 4, and for negative square root of 2, its y value is negative square root of 2 over 4. And so this is the answer.